Hello, sir. Hello, sir. Shall I start the webinar, sir? Sir, voice is audible, sir. Giri, sir.
Am I audible?
Yes, sir. Audible, sir. Sir, shall I start the?
Mr. Shankar?
Yes, sir. Yes, sir. So one second, wait, sir. Good afternoon to everyone.
Why is that I'm not able to hear you?
Sir, not able. It's audible, sir. Sir, now audible. Hello, sir. Giri, sir. Sir. Hello. Hello, sir. Giri, sir. Sir, Giri, sir. Hello, Giri, sir. Giri Prasad, sir.
Shankar, am I audible?
Yes, sir. Audible, sir. My voice is audible. Hello, sir. Hello, sir. Sir, audible, sir.
Shankar, your voice is audible, but Giri Prasad voice is not audible. Shankar, sir.
Giri, sir. Yes, ma'am. Hello, sir. Sir, Giri, sir.
Am I audible now, Shankar?
Okay, sir. Good afternoon to everyone. It's my pleasure to welcome you all to this webinar section as a part of National Energy Conservation Day. Mr. Giri Prasad Ramamurthy, AstraZeneca India Private Limited at Associate Director Facilities, Taramani, Chennai 113. I warmly welcome to our Chairman, sir, Vice Chairman, sir, Director, sir, and Principal, sir. I also extend a warm welcome to Head of the Department, Civil Faculty, HODs and other department faculties and my students. Now I hand over the section to our resource person, Mr. Giri Prasad Ramamurthy, sir. Giri Prasad, sir. Giri Prasad, sir.
കേൾക്കുന്നില്ല സാർ.
Okay. Good afternoon to all. So I think Shankar's network is kind of very low, I believe. So he could not set up the contact, but probably I would introduce myself and start the session. So I am Giri Prasad Ramamurthy. So I head the facilities management for AstraZeneca India Private Limited in Chennai. I'm basically an electrical engineer and an MBA in HR, having 30 plus years of experience in managing plants and machineries in different industry formats, that it be a repair depot or a manufacturing plant or a banking institution or a pharmaceutical plant. So I have varied experience in managing different plants and machineries across for the last 30 years. I was asked to kind of talk about to you all about the energy conservation techniques that are evolving in or that are applicable to industries. Basically, I believe there is a energy. We have the National Energy Conservation Week coming up, so I think your college wanted a person from the industry to talk about energy conservation industry. So that's why I'm here. I'll for the next 20 to 30 minutes. I would talk about the various what is energy conservation and why it is required in industries and what are the different techniques used for energy conservation. Some amount of because while energy conservation is a different subject itself in many of the industries, you would not get many of these inputs from your notebooks or books. Uh, these are not very theory format. Energy conservation, few are theory format, while many are applied based on experiences and the intuition that you or the knowledge base that you have on each of the plant and machinery. So this particular session is not a very theoretical session, but a more insight session, basically to help you understand how you can conserve energy in different plants and machineries in industry. So, so what is energy conservation? So by definition, it is a practice of decreasing the quality of energy for the same quality and quantity of output. So today, for example, you have been uh, using around 100 kilowatt for manufacturing 100 kg of a product. And tomorrow, if you are able to manufacture the same 100 kg of the product with 80 kilowatt hour, then it's called energy conservation. So by decreasing the quantity of energy that you use for production or of the same quality and quantity of a product is called as energy conservation. So how you can actually achieve energy conservation is by efficiently using the energy, uh, by either decreasing the use of energy or by reducing the use of energy. So, so why do you require energy conservation? So, energy conservation at a national level is required so that you can, because when you save energy, it means that you save some resources that has gone into to manufacture the energy. So, you are going to kind of save on uh, financial capital, which is going to increase for the nation. Environment again is going to be safeguarded because today maximum of the energy that electrical energy especially manufactured produced in the country is mainly through coal based power plants. So they generate a lot of greenhouse gases. So by conserving this electrical energy, you are actually decreasing the production of electricity from these kind of power plants. So thereby, you are going to save the environment by doing energy conservation. Again, national security for the term that while you would use lesser coal or lesser resources to produce energy, so you are going to have them in abundance. So you are going to kind of help in safeguarding this kind of natural resources. Again, for even for your personal security for the reason that when you have so many resources, so you can feel you are saving money out of it. So that's again a personal security for yourself. And again, energy can be of different formats. Again, it doesn't need to be only an electricity as an energy. It could be even a heat energy also. So by conserving energy, when you can kind of help in increasing the human comfort, when the electricity or the energy is used for an individual purpose. So generally energy conservation can be found in many of the individual homes. So even in your home you would have seen that to save your electricity bill, you switch off fans and lights whenever it is not necessary. So you are a direct consumer of energy. Similarly, there are some small scale industries, they also use energy. So those are called as direct consumers. They would like to conserve energy so that they can decrease the energy cost, and also by saving the energy while you decrease your energy cost, it means you are saving from your budget. So you get a good amount of security towards your economic freedom. While industries, a big industry like, for example, a Reliance or a Tata, or any other commercial users for that reason, when they would like to conserve energy, because 40 to 50% of the cost goes only towards these energy costs. So while you conserve energy, you can decrease the production cost of their products, thereby you can kind of help in producing more profit out of your business. So that's the reason energy conservation is very, very important, let it be as an individual or a smaller organization or a bigger industrial or commercial organization. What is energy management? So energy conservation is part of energy management. So how do you manage your electricity consumption in an organization or in an industry is basically called energy management. And it has, so energy is managed by three ways. One is by energy conservation, one is by energy efficiency, and one is using other sources of energy. Those are called as renewable energy sources. So what is energy conservation? So energy conservation is more of a behavior based uh, behavior based practice where you don't need a light during a daytime, you switch it off, or if the room is cooler, you may switch off your air conditioner, or for example, when you step out of a room, you switch off your fans and lights from the room. So those are all energy conservation measures. So these are more of behavior based energy conservation. Energy conservation, so basically it's a behavior based method of energy management. The other way of managing energy is through energy efficiency. So what is energy efficiency? So what is efficiency basically? Efficiency is a output by input. So for a given input, you produce an output. So an efficiency is increased when for the same output, you you use a lesser input resources. For example, I told you initially, like for 100 kg of product, you consume 100 kilowatt hours of electricity. So the efficiency is one. But however, if you for the same 100 kgs, you kind of use only 50 kilowatt hour of electricity, then your efficiency is two times. Or even if the output is lesser and you use more input, means you are having a bad efficiency. So efficiency is more otherwise called as also productivity. So how do you manage energy through energy efficiency is by using technologies or using better machineries or using better electrical appliances. So how do you effectively use technology so that you would require lesser electricity to manufacture a product or to run a process is called as energy efficiency. You'd have seen even within your residence also a 5-star rated refrigerator or a 3-star rated air conditioning. So what are all these? These are all again energy efficient products, right? So they consume lesser electricity and give you the same output, right? So same way only. So energy efficiency is basically using better technology or machinery to which can take lesser energy to give the same output. And the other source of energy management is renewable energy, because why do we again need to do a energy conservation today, or why is it required for us to manage energy is because uh, today energy is scarce, because you produce it by using various input methods. Either it could be a coal or a radioactive substance like a nuclear power plant or a gas power plant. So all these are what? All these are either you use electricity through a fossil fuel, or it could be through a nuclear substance. So all these are what? All these are non-renewable source of energies, right? Non-renewable sources. So once you basically take it out and consume it, you cannot reuse it. So that's the disadvantage of non-renewable source of energy. So you basically start losing your natural resources, thereby your economic freedom or say your national resources, national natural resources gets affected. So that's the reason the other form of usage of managing energy is through renewable energy. So renewable energy is basically you extract energy from either a wind or a sun, like a solar power plant or a windmill or through a hydel power plant. So what are all this? So these are all resources which doesn't get exhausted because there is an unlimited supply of these resources. So these are the three different ways by which energy management is done in industries. I'll pause for a second. I wish to know if people could catch up my English and people could hear me very clearly. Can somebody talk out and say where I've been very clearly audible and is my English very easily understandable? Excuse me. Shankar, can you unmute everybody so that at least I can hear from one student, at least if they have heard me very clearly and my English very easily understandable.
Hello, sir.
Excuse me.
Yes, sir. Hello, sir.
Can somebody speak out, please?
Hello, sir. Giri, sir. Sir, voice is audible.
Yes, sir.
Why is that I'm not able to hear anyone? Okay, since Shankar has told me that I'm audible, I'm going ahead. I don't know if why others are not able to talk. I don't know if it has been muted to you all. Okay, so while we speak about energy management, uh, you have to know that what is the objective of energy management in any industry. So in any industry, basically three three different costs gets into production of a product. One is energy, one is labor, and one is material. So generally, labor and material usually either comes at a fixed cost, or any you cannot make any much changes to the labor or materials. But however, you can make changes to the kind of machinery that you use or the amount of energy that you consume to manufacture the product. So that's the reason energy is the only one input in any other industry that can be easily managed while compared to labor and material. So that's the reason there is a lot of importance towards energy management in any kind of industry. And by managing this kind of while this has a very high potential for cost reduction, what you can achieve is like basically you can achieve and maintain an optimum energy procurement utilization.
because energy is again scarce and it is it comes with a very high cost. So if you are able to manage your energy efficiently, what you can achieve is an optimum energy procurement cost and a better utilization out of that energy. And also it would help you to kind of minimize energy cost, or it can also help you in minimizing wastages that could evolve due to usage of energy. And also we are equally responsible to ensure that the environment is not affected, you don't pollute the environment. So by using lesser energy, what you do is you emit lesser greenhouse gases into the environment, and you basically are able to conserve the environment equally.
So the saving potentials in any industry. So basically, industry. What is industry? Any industry would have machineries, right? An industry is an addition of machineries, labor, and material, like I spoke. So many of the industries, the machineries basically are either operated in a thermal format or a electrical format. So either the machinery is run by thermal energy or it is run by a electrical energy. So some of the thermal energy products are basically boilers. Boilers are first thing that or forges, or these are some of the machineries that use thermal energy. While 80 to 90% of the industries use are only electrical energy. So electrical energy is used to run compressors, motors, chillers, and and diesel generators, pumps, and refrigerant machineries, etc. So let us go through what can how can you kind of save electrical energy. So while I'll first touch upon a high level about how you can save electrical energy in an industry, but I'll go step by step into different kind of machinery that we use in industries and how you can save energy there. So in any of the industries, so generally the kind of power that we get is high tension power. So while while the electricity that you use in your home is basically a low tension power, while industries are supplied with high tension power. So this high tension power, it is key that you maintain a power factor. So what is power factor? The power factor is again a very technical term. Basically, you can, if you have read electrical engineering, you would be knowing what is power factor. So it is the lag between a voltage and current. So it's basically available. You can see this power factor basically in a three-phase power supply, three-phase are alternating current power supply. So if you try to improve or if you try to minimize the lag between the voltage and current, so you can basically ensure that you can prevent lot of losses related to electricity. Okay, it is so while you try to improve the power factor within the high tension distribution lines, what you can basically do is you can first, one thing you can do is save straight away, save the peak load charges, number one. And also it could also help you in kind of avoiding any losses. And also second thing that what you can do is ensure that you uh, you do not, so generally the motors in any of the industries are reused very often because they have the ability to kind of be rewound. Means once the binding in a motor gets burned, so what you can do is you can remove that copper wire and rewind it again. But as and when you keep rewinding these motors, there is an efficiency drop. So the for example, a motor is expected to run at 1,000 RPM and give a torque of 10 Newton, for example. So while you try to rewind this motor, so for every rewinding, it loses its efficiency by 5%. It means that it can basically the RPM can go down, or the torque or the pulling power of the motor can go down. So either the RPM, what I told, for example, 1,000 RPM,
can go down to even 990 or 900 RPM, or the torque, that the initial torque that it can give, for example, 10 Newton, can go down to even a 9 Newton or 8 Newton. So what happens is that the motor that is intended to kind of give a output will will be lost if you try to keep rewinding and using the motor. So it is generally recommended that after 2 or 3, if it is a light loaded motors, you should not be reusing that motor after 2 to 3 times of rewinding. However, if it is a heavy motor, after 2 windings, it is largely recommended not to reuse them. Okay. Third thing that you can generally use is, wherever you use motors, you should be using a variable frequency drive. So what are variable frequency drives? Variable frequency drives are those that will help you in kind of regulating the speed of the motor by providing a lesser current to the coil. So this variable frequency basically does that job. When you want to decrease the speed of a motor, what you can do is you can either give a lesser current or a lesser voltage. So here, this basically variable frequency drives would kind of regulate the current that is provided to the motor winding. So thereby, the kilowatt hour that is consumed by the motor comes down, and you can save energy. Again, in terms of pumps, so in terms of pumps, you will have to see for fluid couplings. Uh, Basically, there also fluid couplings basically also helps in regulating the pump pressure in which will eventually go to regulating the speed of the motor. Okay. Now let us speak about each of the machinery that you generally find in any of the industries. Okay, electrical motors are generally found, at least 90% of the machineries that are run in any of the industries are generally either run through a motor or through a boiler. Okay, so uh, I think it's motors, sorry, not boilers, motors. So what does a motor basically do? Motor basically, it takes electric current and converts it into a mechanical energy. And this mechanical energy is either used to kind of uh, it's used to either kind of pump air or pump fluid or do many other purposes. So, but otherwise, the basic objective of any electrical motor is to convert electric current into a mechanical current. And almost 70% of the machineries that are used in industries are driven by these kind of motors. So it is so while so if you try to see, 70% is a very high number, right? So therefore it is very necessary that when you pick up a motor, you need to ensure that those motors are energy efficient, and and uh, and if it is a low loaded motor, then use a star connection against a delta connection winding motors. Please use voltage, variable voltage frequency drives, or VFD drives for speed control of motors. Wherever you need different speeds for different kind of functions, better to use is a multi-speed motor. So a same motor which can run at different speeds. So you'll have to pick up that kind of motor against a motor for each kind of speed. And also you can optimize the operating voltage level for lightly loaded motors. So again, motors run on electricity, while I told, and also I told you, like, either the speed or the torque can come down if the voltage or the current is not optimum for that motor. So you would have seen even in our own house, a fan doesn't run at a good speed if it is a low voltage, right? So it is you'll have to ensure that for any electrical appliance to operate, it has to have the optimum voltage level. And similarly, wherever you have idle runnings in between operations, please ensure that you provide interlocks so that the motor is stopped there, and during idling you don't need to even operate such motors. Okay, avoid frequent rewinding of motors, like I told you earlier. And last but not the least, Any machinery can be efficient only when there is a regular preventive maintenance done on these machineries. So until unless you don't monitor the condition of these machines or you don't do a regular maintenance of these machineries, it will not operate efficiently. So it is very necessary that you have a regular plan of preventive maintenance for all these motors, and you monitor and ensure that these motors are being maintained on a regular basis. And similarly, when you use an energy efficient motor, what can happen is it will consume lesser electricity, thereby you can reduce operating cost. And also motors comes with different kind of losses. So there could be a friction loss called a heat loss or a Faraday's loss. So all these losses are minimum or nullified with if you have an energy efficient motor. And also while you use the energy efficient motor, what happens is that you will have a extended winding lifespan because these motors are don't draw much current. So generally these windings and motors burn away because of higher current passing through them or intermittent higher current passing through them. So thereby they weaken the insulation of those windings and they short with each other and they burn. So and that requires rewinding. But when you use a energy efficient motor, what happens is that the current that the winding would be able to accept that amount of current and the insulation or heating doesn't happen, which would lose the insulation of such windings. So lesser number of winding will happen, rewinding will happen, these kind of energy efficient motors. The next kind of machinery that you can see in industries is air compressors. So if you see at least 60 to 70% of operations that happen in many of the industries, mainly industries like automobile industries or any other manufacturing industries for that reason, they use a lot of air air pressure either for operating any machinery or for even conveyors or for instrumentation purpose, etc. So air is a very is a nerve center of many of the industries. So they use a lot of air compressors, and these air compressors are again run with help of a motor and a compressor. So it is very necessary that when you operate a when you want to kind of have an air compressor for your own industry, so you'll have to ensure that you the 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 compressor that you pick up is right for your industry purpose. For example, if you want an air pressure of, for example, 100 pounds, uh, then you'll have to kind of pick up an air compressor that could kind of only give you 100 pounds against a compressor of 200 pounds or a compressor of 50 pounds. So it is very necessary that you select the right kind of compressor for for your industrial purpose. First thing. Second thing, what you might need to also do is that the compressed air is put into the right use. Many of the times, even I have seen in many of my industries that compressor air is used to either clean the floor or to kind of clean some their own bags also. So compressed air is used for very irrelevant purposes sometimes in industry. So ensure that the compressed air is used only for the purpose it is intended to. And similarly, what does a compressor do? It takes air, compresses it, and stores it with a high pressure. So generally, if the air is cold, the air is already denser. So when the compressor pulls such air inside, the amount of effort that it has to take to compress that air will be lesser compared to a hot air, because hot air are not denser in nature. They would be rarer in nature. And so the compressor will take more time to kind of compress such air. So it is every time good that while you try to look out to place a compressor, so just ensure that the inlet wall or inlet filter of the compressors are kept at a cooler place so that they absorb cool air and the compression time is lesser, thereby the motor running time is lesser, and the amount of energy used for
compressing that air will be lesser. Also, ensure that whether air at low pressure can be used for a process, because sometimes what you do is that you might need only a 10 pounds of air, or a 10 kg per centimeter square of air for for a particular machinery. What you might do is that you end up switching on a 100 kg per centimeter square compressor. So what actually you are doing, you are not using the right compressor or the right amount of air for that particular purpose. So you'll have to ensure that wherever you want a low air pressure, you use those kind of compressors instead of taking connection for air from a bigger compressor. Again, leakage is another one big thing that you can generally see in industries. They, if a compressor pipeline is leaking, actually it is a loss to a company. Ensure that none of your airlines or the air supply lines are having any leakage. So there should be a regular inspection mechanism and a maintenance mechanism of all this air supply pipes to see that none of the air pipes are leaking. Okay, and also you have to measure the the average electricity consumption of these compressors, because over a period of time these compressors become lesser efficient and thereby they can draw more current. So it is very necessary that you keep monitoring the performance of these compressors in terms of electricity consumption. So wherever you see it is consuming higher electricity, then you might need to find out what is the problem with the compressor and kind of correct it, so that it consumes lesser current. Okay, I pause here for a minute to understand if there are any questions. Are there any questions? Still, I'm not hearing anybody. Okay, if you have any questions, please post it on the chat. I have more 10-15 minutes to cover this. So if you have any questions, please post it on the chat. Okay, so the other kind of machinery or the equipment that is used in industries is a cooling tower. So cooling towers are basically uh, machinery used to kind of provide chill water for different applications in the industry. So generally there are two kind of cooling towers. One is an air cooled cooling tower and a water cooled cooling tower. Uh, Industries generally use a water cooled cooling tower because it is more energy efficient than a air cooled cooling tower. Okay, and what this cooling tower basically has is a air and water. So basically in a cooling tower, what happens is like the tower gives on one direction, it gives a mist or a rain kind of a water spray, and there is a water line that flows in between a medium where on the top it gives it's a chill it's a rainwater kind of or a mist kind of water spraying, and from below it kind of pushes air. So this mixture basically cools the water pipeline that goes through it, and that carries the chill water to different applications in the industry. Many of the industries uses these coolings for either cooling some of the machinery, number one, or for air conditioning purpose also, for centralized air conditioning purpose also. So this again one of a major
major energy consumer in many of the industries. So it is necessary that you have the machinery in such a, because there is a constant exposure to water and moisture through the air. So there's a lot of rust that may happen to the fins or to the pipelines or even to the fan blade. So it's very necessary that you kind of replace these fan blades with a more synthetic fiber blades, or called as FRP blades, that is fiber reinforced plastic blades with a aerofoil design, because aerofoil design would make to kind of help in kind of cutting the air easily and throwing the air upwards. So this can help in saving energy again in many of the cooling tower plants, and also ensure that you have a automated mechanism. So once the chill water attains a particular temperature, desired temperature, could be a 6 or 7 degrees Celsius, automatically the plant should switch off on its own. So you should kind of have those kind of automatic on-off switches controls, and so these are some few things that you'll have to look at a cooling tower perspective. Also, you'll have to see the kind of water that you use. So you should not be using an ionized water or a hard water for again cooling towers, because the this will again cause one is rust, and it can kind of affect the thermal carrying or the cooling capacity of this waters, which can kind of uh, uh, allow to higher electricity consumption. Again, that is one thing that you'll have to look in a cooling tower. Also, the chill water line after going out of the cooling tower should be properly insulated so that it doesn't lose the temperature while it flows through those pipes to that particular output mechanism. So ensure that those are being insulated properly. And the other kind of thing that you can see very often is pumps. So pumps are basically used to transport fluid, basically oil. In oil is the major item that gets transported through these pumps at a very high pressure. So they are used either for the hydraulic presses or for any other purposes uh, within the industry. And again, these are driven by motors. So you'll have to uh, uh, ensure that these pumps are working fine, efficient enough, and you'll have to select the right pump capacity for a particular application, because if you don't use a right pump, either you use an overrated pump, means you are consuming more energy for a lesser effort, or or you might end up if you try to take a lesser capacity pump for an operation, again it can fail the operation. And so it is necessary that you select the proper pump and the motor rating for the pump that you are going to operate. Okay. And second, matching the motor is again equally important. um, then again, while the flow of the fluid is today maintained either through a throttle valve. So you can see a circular valve that basically controls the flow of these kind of fluid. What you can do is you can use a variable speed drive. Why you should not use a throttle drive is because throttle valve is because the motor will run at its 100% capacity, while the application might require only 50% of the capacity of the pump. So what is happening is that while you use a throttle valve to regulate the flow of the fluid, but you are not regulating the power consumption at the motor level or at the pump level. So if you use a variable speed drive, that will basically control the flow of the fluid, and thereby even you can conserve electricity from these kind of motors. Okay. Again, equally important are the shaft alignments, pipe leakages, all this, and drive transmissions. All these are very necessary for ensuring that you don't lose any of the energy that is spent in transporting those fluids through this medium called pump. Okay. And similarly, the belt that connects the motor to the pump should be a V belt. Should not be a V belt. It should be more a flat synthetic belt, so that there is lesser friction and the power of the motor is directly transmitted to the pump. Another thing that you can very often see in few industries is the refrigeration and air conditioning. Uh, these are generally used in food processing industries. Again, what is basically refrigeration? Refrigeration is either removing heat from a low temperature level or rejecting heat at a high temperature level. So removing heat is like already the place is cool. You want to make it cooler. What you do is that you inject more coolness into that place. Thereby, it will absorb all the heat around that place because there's heat energy. Basically, what it does, it passes from one higher medium to a lower medium, and it passes on until it has reached equilibrium. So between a hot and a cold substance, hot substance is a higher energy medium and a cold substance is a lower energy medium. So the heat basically passes from a higher medium. So generally when you try to keep a hot substance and a cold substance, the heat gets passed from the hot substance to the cold substance. So that is the same thing in a refrigeration principle. So it will kind of remove that heat at a lower temperature. Similarly, it will reject heat at a relatively higher temperature. Uh, so a place is cold, a room is cold at a 20 degrees Celsius. The ambient temperature is at at a 30 degrees Celsius. So what basically the cool room will do is that it will stop that hot air to come in. So it becomes a barrier between that room and that external environment. And so that same thing which again a refrigeration does. Okay. Air curtains basically are those kind of formats which kind of rejects either heat into a higher temperature level. Okay. So while operating these kind of equipments, ensure that your windows and doors are closed so that it's a closed environment, and also ensure that if you're using a double door or any door, use an automatic device to close the door automatically wherever it is required. And also ensure that the condenser coils are properly maintained without any rust or algae, because you need to have a proper heat exchange. Similarly, the compressors of these air conditioners should be maintained properly, should be located in a place where it is no much direct sunlight or any heated surface, because this compressors basically compress air and the input to the tire should be a cooler air. So if you try to keep it in an open, in a hot air place, basically it can kind of uh, 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 it will take a longer time to compress those airs. Okay. Similarly, power consumption should also be measured regularly with compressors to ensure that they are working efficiently. Okay. Similarly, the duct system that are used uh, uh, for uh, for the transmission of the cool air should be completely sealed and insulated so that it doesn't lose its coolness during its transportation. Next is lighting. Lighting is again measured by a unit called as lumen. Okay, and and another term in lighting is efficacy. So efficacy is nothing but the amount of lumen produced per kilowatt of electrical power. Okay, so wherever in lighting, ensure that you replace all your conventional ballast to a electronic ballast, because conventional ballast will have this only, or called the choke, will have hard capacitors and coils which have a higher source of energy loss. So if you use an electronic ballast, it's uh, what do you say, a semiconductor product. So there won't be any heat loss. Okay. Similarly, you'll have to use uh, CF or LED lights wherever possible and replace them and replace the conventional incandescent lights with these kind of CFL and LED lights, and also ensure that the fittings are being cleaned properly. Also, wherever the lumen required is lesser, use a lesser rating of light fixtures. Similarly, sodium vapor lights can be replaced, can be used to replace the mercury lights, so that because it also gives a very good savings of electricity. Okay. Again, thermal energy. I told you about. Now we spoke about electrical energy. There is something called as even thermal energy. Thermal energy is basically basically you can see those boilers and all produce thermal energy. So what you need to do for thermal energy saving is you'll have to kind of continuous, there should be a regular audit that you need to do to ensure that there is no oil leakage, there is no heat leakage, the oils that are being used are being uh, filtered properly at different stages so that you are able to combust that oil fully. If there is no proper combustion, again there is either a heat loss, or that means the thermal energy that needs to be produced is lost, or you end up consuming higher fuel for producing the same amount of thermal energy. Similarly, you should have a maintenance which very clearly indicates a culture of zero leak philosophy. I've seen in many of the boilers there will be a continuous leak. The technician will not even go and repair that leaks. These leaks, while they look very negligible, but on a long run, it can kind of give losses up to even 250, 300 liters of furnace oil. So it is very necessary that you should not have any leak in any of the boilers. Similarly, boilers I told are used for converting or to convey heat in different formats. So basically, one form of while I spoke about cooling towers and refrigeration, they use water to kind of transport the coolness to an application. Here, boilers basically use steam to kind of steam as a medium to kind of take heat to another to an application. Okay, and the kind of fuels that are used for boilers are basically coal, oil, or gas. Again, all these are coal or oil or gas are basically more a fossil fuel. So it is necessary that these kind of sources of energy should be kind of managed better. Otherwise, you would one day lose it for our other generations. Again, while you use water to produce steam, ensure that waters are kind of treated properly, because they can form scaling in the pipelines and it can disrupt the flow of steam or the effective passage of heat from one place to another. Again, steam leakage should be stopped, I told you, right? And also the insulation should be done properly to disallow any loss of the heat energy while transporting the heat through the steam. Another energy source is diesel generators. Diesel generators are used in different formats. One, either it would be used as a main source of energy for producing electricity. Few industries use them as standby. Whenever the power supply from the grid fails, they use the diesel generators for producing electricity. And few also use it during the peak hours, peak load hours, while they don't get enough electricity from the PNEB grid. They use diesel generator as a complement energy source to run the operations. So diesel generators are again equally and very important uh, plant machinery in any of the industry. So ensure that you maintain them properly, and see that injection pumps or filters are being maintained or repaired or replaced regularly. Ensure that you measure the fuel consumption for every kilowatt produced by the diesel generators. Wherever you see the diesel consumed is more and the power generated is lesser, immediately look out for the snags or say the root cause for such problems and kind of correct it immediately. Again, another form of energy management is energy audit. So audit basically is kind of see what it is as is and kind of compare it against a standard or say a design and kind of verify it, and then by even monitoring and analysis you give a report, a technical report which says what is running correctly, what is not running correctly, and what you can do to kind of run it correctly so that you reduce energy consumption. So this is the basic objective of any energy audit. So how you do an energy audit is basically you can do it in two formats. One is a preliminary energy audit and one is a detailed energy audit. So preliminary audit, it covers basically it establishes or say it looks at what is your energy consumption that's happening in a plant, and basically get all those data and and identify what is the most easiest and likeliest areas of attention that you need to look out uh, for basically to conserve energy. So they preliminary audit does nothing but compare against the standard and see what you consume and basically give your recommendations. However, a detailed energy audit will look into more in detail of all these items. They would kind of first come as an energy audit team. They would first gather data. They would also do some sampling checks or do a measurement on their own to see what is the actual consumption of each of this equipment. Then they would do a energy loss or a waste analysis. Where are the energy being lost? Where are we wasting our energy? All that is done, and then they identify and develop energy conservation opportunities and propose it to the organization, along with what is the cost that you would involve in making those changes, what is that you will save. They will try to convert that into a money value, like either a dollar or a rupee, and they will say you can recover this money for the spend that you would make in so many years. So that's called as payback period. So they would do a cost benefit analysis along with the payback period, and they will report all this to top management, and they will ensure those are being implemented, and they will ensure that they track it and close it till all the recommendations are being implemented by the company. Another source of energy is the renewable source of energy. Like I spoke about, they are obtained basically from inexhaustible sources like sun, wind, or water. They convert these kind of energy sources into electrical energy. They can either be in form of sunlight, wind, water, sea waves, geothermal heat, or even from biomass also you can manufacture, you can produce electricity. Okay, different type of renewable source of energy are solar energy, wind energy, hydro energy. Hydro energy is energy you produce from running water. Biomass, again, geothermal energy is also one form of renewable source of energy. So this comes to the end of my session. Any questions till now?
Hello, sir.
No questions?
Participant,
Or
any
you can
queries,
type
please
on the
raise.
chat. I don't know why I'm not able to hear any of your. 1 minute, let me see.
Participant, any queries, please raise.
I'm sorry, I think I have kept my speakers. This one. Can somebody talk? Let me try to hear.
Any queries, please raise your voice and chat box.
Can I have somebody talk?
Hello, sir. Audible, sir.
Yeah, audible. Sorry. Actually, it is a mistake from my end. I have muted my speakers.
Okay, sir.
Extremely
Okay,
sorry.
sir.
Any questions?
Participant, any queries, please raise your voice.
No questions from students. I'm very surprised.
Okay, okay. Sir, few minutes, sir. So all the participants, please switch on your camera. Hello, participants. All the participants, switch on your camera. Ma'am, நினைக்கிறேன். உஷா நந்தினி ma'am. All the participants, please start video. Wait பண்றேன். Video on பண்ணாங்களா ma'am? Okay. Please switch off your video and all the participants, please fill in the feedback link. All the participants, please fill in the feedback form or chat box link.
So if there are no questions, can I leave the meeting, Shankar? I think it's more an administrative work for you. Shankar?
Okay, sir. Thank you for your nice lecture, sir.
Wish you all the best to all the students. Bye-bye.
Thank you, sir. Thank you so much once again.
Thank you, sir. Thank you, sir.
All the participants, please fill the feedback form. Okay, leave the meetings.